So, good morning, everyone. My name is Chris Angelo Hornales, and I am the first reporter of Group 1. For today's report, we will talk about boiling point elevation. So, before I proceed, let us define first what is boiling point elevation. Point elevation is the phenomenon that occurs when the boiling point of a solvent is increased when a compound is added. So basically, during this experiment, we were able to evaluate and determine how the amount of solute influences the increase in boiling point of a liquid. Next slide, please. So for this activity or experiment, we have three objectives. First, we have to prepare for containers with 100 ml of water and the respective amounts of sodium chloride. Second, observe for its boiling point while submerged in a hot water bath. And lastly, record the results and complete the table respectively. Next slide. So during the experiment, we used these materials. We used beaker, stirring rod, water bath, water, sodium chloride, and calcium chloride. So I'd like to pass the virtual floor to Ms. Guanzon for the continuation of the report.
Thank you, Chris. Good morning po, ma'am. Am I audible po?
Yes, sige, may continue.
Okay po, thank you po. So for the procedure, we have here the number 1. We had prepared 4 beakers with 100 ml of water each, then labeled them from A to D. So for container A, we had 100 grams of water, then placed it over a hot plate, and then recorded the boiling point temperature. For the second container, which is the container B, we have 100 grams of water plus 2 grams of calcium chloride, then place over hot plate, and then record the boiling point temperature. Same with the container C, we had 100 grams of water plus 4 grams of chloride, then placed it over the and then we had recorded the boiling point temperature. And also with the last container, which is the container D, 100 grams of water plus 6 grams of calcium chloride, then placed over the hot plate and recorded the boiling point temperature. So for the solution or the next part, I'll be giving the virtual floor to Ms. Romualdo.
Hello, ma'am. Good morning. This is for the solution of the computation for solving the boiling point elevation of the 4 different types of solutions. So first is the container B, which is containing 2 grams of calcium chloride with a 100 grams of H2O. In computing the boiling point elevation, we are going to use two formula using the molality and the formula for our boiling point elevation. The first thing we are going to do is to compute for our molality here. Our first solution contains 2 grams of calcium chloride over its molar mass, 110 grams per mole, over its kilogram, which is 0.1 kilograms of H2O, which will give us the answer 0.181818 molality. Next is to compute for its boiling point elevation using the formula Kb constant times its molality. The Kb constant of the water is 0.512 times our molality from our solving, which gives us the answer 0.09, 30, 90, 90, 98. In computing for our final boiling point elevation, we are just going to add our initial boiling point, which is 100 degrees Celsius, plus our initial answer from our boiling point elevation, which is the 0.09, then will give us the answer 100.09. The same thing that we are going to do for our container C, which contains 4 grams of calcium chloride and 100 grams of H2O. First is we are going to compute for its molality. 4 grams of calcium chloride over 110 grams molar mass over the kilograms of the solvent, which is 0.1 kilogram, which will give us the answer 0.36 molality. Next is for its boiling point elevation, 0.512 for the Kb constant times the molality 0.36, which will give us the answer 0.1861, 81, 81, 82 degrees Celsius. For computing the final boiling point elevation, we are just going to add 100 plus the boiling point elevation, which will give us the answer 100.19 degrees Celsius. And lastly, for container D, which contains 6 grams of calcium chloride and 100 grams of H2O, first we are going again to calculate for its molality. 6 grams over 110 grams of molar mass over its kilograms of solvent, which is again 0.1 kilograms, then will give us the answer 0.05454545455 molality. For computing its boiling point elevation, again, we are going to multiply the Kb constant, which is 0.512, times the molality from our computation, which will give us the answer 0.02792727273. And for computing the final boiling point elevation, we are just going to add 100 plus our boiling point elevation, which will give us the answer 100.28 degrees Celsius. That would be all po.
Thank you, IC. For the results, we have the experiment. Experiment A, pure water. Experiment B, water plus 2 grams of calcium chloride. And for experiment C, we have water plus 4 grams of calcium chloride. And for the experiment D, water plus 6 grams of calcium chloride. And for the theoretical boiling point, we have 100 degrees Celsius. And for the experiment B, we have 100.9 degrees Celsius. And for experiment B, we have 100.19 Celsius. And for the last experiment, we have 100.28 degrees Celsius. And for the experimental boiling point, we have, for experiment A, we have 98 degrees Celsius. And for experiment B, we have 98 degrees Celsius. And for the experiment C, we have 97 degrees Celsius. And for the experiment D, we have 96 degrees Celsius. Next reporter, please.
So for the guide question, explain why salt in your water is only to add flavor and doesn't make your food cook faster in any significant way. So adding salt to water only adds flavor to the water, then it absorbed by food, but it doesn't make your food cook faster. It will depend on how much salt you put into your water. Certain amount of salt raises the boiling point, but does not speed up the process. But if we want to speed it up, we can just add more salt. But if we are actually cooking at home, we wouldn't want that much salt on our food. A little go a long way to make our food taste good, and too much can ruin the taste of our dish. So next reporter, please.
For the conclusion, boiling point elevation is a colligative property of a solution. The amount of by which the boiling point rises on the addition of solute may be computed using the boiling point elevation constant and the molality of the solution. Boiling point elevation is the raising of a solvent boiling point due to the addition of a solute. This implies that the innovation in the boiling point of a solution depends on the amount of a solute added to it. And that's it.
Okay. Sige. Question muna. Why do you think the your actual result sa experiment is not really the same with your computed theoretical values for the boiling point? Have you researched about that? Since you have presented that sa inyong results. I hope you included that in your conclusion na sinend niyo sa akin. Kung bakit merong discrepancy. Kasi looking at your report kanina, for example, sa 2 grams, that's 100.09 degrees Celsius for the theoretical value of the boiling point. However, sa actual experiment ninyo, it was just 98 degrees Celsius. And the trend is the other way around. For the theoretical boiling point, it's increasing. As you increase the solute, the boiling point also increases. However, in your experimental data, as you increase the solute, there is a decrease in the boiling point. So, have you explained this in your conclusion? Or na-research nyo ba bakit? Bakit kaya? How about the other groups? Ganito din ba yung result ninyo? Like, hindi nagtugma si theoretical boiling point and si experimental. Decreasing din sa inyo. Okay. Sige. I hope you included that one in your discussion for the conclusion. Maybe sa pag-wait. Okay. Sige. Pero I have checked this one kagaya na sa percent ni IC. The theoretical boiling points are correct here. Do not forget to compute first for the molality. Molality is moles of solute. So for example, 2 grams. Calcium chloride ito. Wait lang, saan nga yung pen ko? Here, writes the screen. This is calcium chloride. Okay. Kalimutan ng 2. Anyway, sa theoretical boiling point, do not forget our 3 formulas. Number 1, for the computation of molality, we have molality is equal to moles of solute. This is for the solute, So that is calcium chloride in the case of the experiment, over kilograms of solvent. So our solvent here is water. So do not forget, 1 gram ng water is equivalent to 100 ml. So if you used 100 ml of water, that is equivalent also to 100 grams. And if you are going to convert that into kilograms, that is 0.1 kilogram. Okay? Compute yan. Ay, hindi pala 3 yung ating formula dito. 4 pala kasi before you can solve for the molality, you have to convert first grams to mole. So ito yung paulit-ulit natin na formula for that. Moles is equal to weight of the substance divided by its molar mass. Pag na-compute mo na ang molality, you may proceed with a computation of the change in the boiling point. Okay? This is equal to kbm. So kb class again is the boiling point constant. It's constant. You just have to look at the table. I'm not asking you to memorize everything. It's just that we always use water since water is the universal solvent. So you have to be familiar. It's 0.512 degrees Celsius per molal. And then the small letter m there is the molality, the molal. Okay? But if you are computing for the exact boiling point, this is just the change in the temperature. So for the exact boiling point, our final boiling point class is equal to the initial boiling point, that's the original boiling point of the solvent, plus the change in the boiling point temperature. Okay? And then again, we will really expect that the theoretical boiling point may not be true during the actual experiment, because during the actual experiments, we have a lot of sources of variation. So it may be due to the procedure na ginawa natin, or hindi natin talaga nasunod yung procedure, or yung sa equipment natin. Example, sinabi dyan 2 grams, but for example, our analytical balance is not really calibrated. So it will read there 2 grams, but sa totoo, hindi talaga, example, umabot ng 2 grams or sumobra siya ng 2 grams. So merong discrepancy na yun. And then meron din tayong environmental factors, the atmospheric pressure. Take note, when you say boiling point, the atmospheric pressure, the pressure outside your container or the environment should be equal to the vapor pressure of the liquid. So it may be due to the atmospheric pressure class, hindi talaga siya maaabot ng 100 degrees Celsius. Okay? Pero the downward trend, I'm not that sure with the downward trend with your experimental boiling point. It is supposedly increasing. Okay? Pero meron talaga yung discrepancy kasi maraming factors na mag-contribute to the result of the actual experiment compared to the boiling point. Okay? Do you have questions? Wala? Sure. Isang question lang meron tayo dito, di ba? Yung salt. Ginagamit lang siyang condiment class. That is to give, flavor sa dishes natin. But it will not really make our food cook faster. Kasi ang effect lang nun, since salt is a solute, it will just increase the boiling point temperature. Mag-i-increase lang siya, matagal magbo-boil na yung ating binoboil. Again, in the presence of too much salt. But it has no direct effect with that of the rate of cooking. Okay? So again, both condiment and solute lang siya, pwede niyang ma-increase yung boiling point. Walang question for activity number 1. How about sa computation? Questions, clarifications about that? Yan, sa report ni IC. Tama yan lahat. 100. Siyempre, water theoretically will boil at 100 degrees Celsius. If you add 2 grams of calcium chloride, that should be 100.09. Hindi naman masyadong malaki talaga yung increase in the boiling point. There is an increase, but it's not really that big. So, kung hindi talaga natin siya masyadong mapapansin sa thermometer. Especially wala namang point yung thermometer na ginamit natin last time. Okay? So walang questions. So that's it for the report of Group 1. Thank you, Group 1.